How did you do for your x-intercepts and y-intercepts? It's already factored, making our x-intercepts easy. Plug in 0 for x, making your y-intercept easy. Any non-permissible values? No. So no vertical asymptotes. And one way to find the horizontal asymptotes is looking at what happens when x goes to infinity. So we can sort of review some of our limits unit. If I do the limit as x goes to positive infinity, this gets big, the whole thing gets big. As x goes to negative infinity, to the 2/3, what happens if I would do a number like -8 to the 2/3? Well, the third part is a cube root. So that would be -2, and then the squared part would make it positive again and make it full. So this number is going to be positive in the end. If I go to negative infinity, this will be a big negative number. This actually should go to a large negative number in the end, because this will be positive and this will be negative. Okay, so now we go to our derivative. So curve sketching, the idea, find x-intercepts and y-intercepts, find asymptotes. Once you've done that, go to your derivatives. Your first derivative is going to find stationary points, critical points. They might be maximums, minimums. Your second derivative is going to find possible inflection points. You do your number line for both of them to see where your graph is increasing, decreasing. That also tells you maxes and mins. You do your number line for your second derivative to find concave up, concave down. You take all of that information and the points that you have, and hopefully you feel comfortable in finishing your graph. So, first derivative. Do you see that it's a product rule? Keep one the same, derivative of the second. Keep the second the same, derivative of the first. So the 2/3 would come in front, subtract 1 from the exponent, and you would get a 1/3. And what I did here is I mean, you don't have to simplify, but if I want to solve when it's equal to 0, it sure makes sense to get that common denominator, and then the only place it's going to equal 0 is if your numerator is equal to 0. So you would get x equals -8/5. Now we have to do our second derivative. Can you see that your second derivative would be a quotient rule? Keep the bottom the same, derivative of the top, minus keep the top the same, derivative of the bottom over the bottom squared. Okay. I actually want to do a little bit different. Yeah, I'm going to erase this and simplify it with you guys. Can you see that you have a fraction in this would be over 1. You have a fraction in the top, you have a fraction in the bottom. There's a couple ways you can go about this. You could get a common denominator in the top, so you get one fraction on the top over something, and then you have to multiply by the reciprocal. I do want to show you, though, a nice little shortcut technique that gets rid of fractions within fractions. In other words, we have this x to the 2/3 is on the bottom and is causing us problems. So what I'm going to do as a nice technique is I'm going to put this whole top in brackets, and I'm going to multiply it by x to the 2/3. Because if I multiplied everything in the top by x to the 2/3, can you see that that would get rid of the bottom, which is causing me the problem? But if I multiply the top of a whole fraction by something, I need to multiply the bottom of the whole fraction by something as well. Same thing. What will this do? Well, this x to the 2/3 will distribute to both of those, which will get me, how do you multiply powers with the same base? Add the exponents. So do you see that this will be, well, I can put the 3 in the, be okay if I put the 5 and 3 and make 15, and then x to the 2/3 times x to the third will just be an x. Minus, and here when I multiply this term, well, that my x to the 2/3 just cancel out, giving me the 5x plus 8. Keeping it in brackets because we're subtracting all of it. Over, add the exponents, 9x to the 4/3. If I set that equal to 0, then the top has to be equal to 0, which is now 10x minus 8. And so x is equal to 4/5. Just a nice algebra technique to know about with fractions. We can do our number line with the negative 8/5. And we have a non-permissible value in our derivative, because now we're dividing by x to the 1/3. So that is a critical point as well. It needs to show up on your number line. Very easy to forget about doing the non-permissible value. You get so used to finding stationary points that you forget critical points also includes non-permissible values. Same thing with our second derivative. We have to include that non-permissible value, even though it's concave down on both sides of it. I'm going to save you some time and not show you those boxes. That's just me writing the intervals where it's increasing, decreasing. I don't think you need to write that down. Can I scroll up and find the points? Has everybody got the diagrams down? So now that you've found all of those things, we can plug things in. Point number 1. At negative 8/5, which we know from our first derivative test that it's a maximum. We also know from our second derivative test, because f double prime at negative 8/5 is concave down, it has to be a local maximum. So both your first derivative test and your second derivative test show you where things are maxes and mins. Point number 2, 0, 0 is going to be a cusp or a corner. I think in this case it's a cusp. You don't have to know the difference between a cusp and a corner. I think technically, I'd have to look this up. A corner is if you did the slopes from either sides, they might be different, but it's still a sharp point. And a cusp, the derivatives on both sides go to positive infinity or something like that, or negative infinity. So they're the same, they technically join to the same thing, even though it's still a sharp point. And here's our inflection point. Of course, you need a calculator for that. Oh, I scrolled too quick. I'll wait. I just want to click on the graph. So here's our graph. We have our maximum, we have a sharp point at 0, 0. It is concave down. Right. Concave down, and this part here is concave up. If I have that curving a little bit like that.